G'day guys, how's it going? So in this video, we're going to talk about heap memory and how it works with Rust. So firstly, what is heap memory? Well, you can see on my left here, I have a little poster of the old classic Tetris game. So if you think about the old Tetris game, essentially you're trying to establish as clean of a puzzle as possible, right? So you don't want any gaps because filling in gaps makes it harder to reach and things of that nature. And therefore, it's not optimized, right? You haven't got a full optimized puzzle. So you have to do other things to move stuff around, or you have to clear lines to get down to where those holes are, right? So heat memory kind of works similar to that. It's not always super clean, but we try to do our best to keep the puzzle clean, so to speak, right? So because of that, and the fact of how the puzzles work in Tetris, we don't always know the size or shape of the piece that's coming next, or not necessarily next, but further on down the line. And so as a result of that, we have unpredictability, right? So the heap will try to address any data that you send that is of an unpredictable size, i.e., it's not a fixed size. So previously, when we talk about stack memory, we were talking about integers and floats and booleans and things of that nature. They all have fixed sizes in bytes, right? So those things fit on the stack just fine. However, there are other types that we haven't spoken about yet, which we don't necessarily know what the size is going to be at compile time, nor at runtime. So the result of that is we have unpredictability. So in that situation, that particular data will go on the heap. Now, because of this, the heap essentially sits in your RAM. We don't really use the CPU as we did with the stack. So I just want to quickly call that out. But the major issue is because the memory and how we allocate is not the most organized because we can't work it out ahead of time, it's a little bit slower compared to stack memory, right? Now, what is actually stored on the heap in Rust? Well, I kind of alluded to it a minute ago. It's basically data types with a size that cannot be determined at compile time. So we haven't covered any of these yet, but one that people might be aware of is the string type, right? So most programming languages, we have what's called a string, and we'll talk about that type a little bit later on in this series. Data that is also shared between multiple function calls, i.e., it could be an integer, it could be a float, it could be a boolean, but if it's being used outside of multiple functions, like a uh, global piece of data, that will also be stored on the heap. Anything that's shared between multiple threads. So again, think of some shared data that could be utilized by multiple threads at any given time. That will also fit on the heap and not be able to fit in the stack. And then lastly, any data that's way too large to fit on the stack. So think of something like an array of thousands upon thousands of records. At some point, that data is not going to fit on the stack anymore. So basically, that will be moved to the heap to cater for the large size. Now, how do we manage data on the heap? Well, like I said, we have a situation where we don't always know what things are going to be in size. So, what Rust and a lot of programming languages do is they say, okay, when we need to assign a value to, say, a variable, in this case, name or address, what we're going to do is on the stack, we are going to reference a location stored on the heap, right? And it's what's called a pointer. Now, it looks a little something like this, right? So we have some value that represents an address in memory, right? So we just get the address and we store that on the stack. And then basically the value itself is stored on the heap. And so when we want to fetch the value of this variable, we have to come to the stack first to look up the address. And then once we have the address, we go to that specific piece of memory on the heap to fetch it. And that is why it's a little bit more slower than the stack, because we have to go to two different places to get the data. First, we need to find out where the data is. We go to the stack. And then secondly, once we know where it is, we then have to go to the heap. So it's a two-part process. And obviously for address, same deal. You know, you will have another address in memory, and that will point to another piece of data in memory, which in this case, I've represented as text. which we refer to as strings. Cool? So that is pretty much all you really need to know about the heap. So in the next video, we'll move on and we'll start talking about ownership. So I'll see you in the next video.